Everybody, it's nice to talk to you again. I wanted to talk a little bit about the assignment that I had promised you. Remember, you worked on the object-oriented design of the cell mitosis, and I did tell you that I want to turn this eventually into an animation. So here is the posting for that, and I have some things to share with you. So you're going to be using what you have from the one that is not a simulation, just the narrative, just text-based. You're going to use that format to actually turn it into an animation. So you have the narrative or the script, whatever you want to call it, and now you would like to have the animation, the images that go with it. So if I was going to look at some of the stuff over here, let's take a look at if you click on this one. This was is an example. Click on that. It's going to take you to, I believe, you're going to see how this is actually going to start splitting into two cells, exactly the same as the original. Pay attention how simplified it is. It doesn't have all the details that you will need for a real simulation. But that's what an abstraction is, right? We're looking at something that is a simplified version of the real thing, so you just concentrate on very specific things. I like this because you're going to see how well they both are identical and they separate into two. You're going to see in a minute that they become, there you go, and they're both exactly the same as the original and it's as each other, right? Let me post this, otherwise it goes into crazy stuff. The problem with this is that it's missing that narrative that you created in the text space. Well, one thing is that that narrative doesn't have to be exactly the same for the simulation. You might be in a situation in which you might want to change the narrative. I'm fine with that too. If you click on this one, that will take you to the class website. And here it is. And here's where you have the tools. And once again, we're going to be using something that you learned a long time ago with the bouncing ball. In this case, we have something called the bouncing ball. Different because instead of drawing the ball, it's using an image. And that's what you're going to be doing, using images to actually create this simulation. I believe it takes other formats. PNG seems to work very well for me. Everything else is pretty much the same as the bouncing ball. The only reason why it's called deluxe is because it's using an image. So how do we turn this into an object-oriented design? So, well, what is it that I want to separate from here? I want to create the ball, an ADT called ball, because the ball is where all the information that you need for the simulation is. The ball has the position. Here is the position in X, the position in Y. The ball also has the velocity, once again, split into the components of X and Y. And you need to have the radius of that ball, right? So then since these instance fields are all about, that belong to the actual class, the ADT, we made them private for encapsulation purposes. So there is a consistency behind each of those balls. At the same time, they are protected. Any changes you had to make or you want to make to the ball, you're going to have to use the mutator or set of methods. Here we have the access or methods. I could have called it get Rx, but it was just a little bit too much to type, so I thought just call it Rx. So these two are the getters or access or methods. And then you have the mutator of methods in which allows you to make changes to Rx and Ry. Um, so what else do we need to know? We also need, we also need um, to get information about the velocity. And I wanted to show you one way that I've been talking to students whenever they come to me. Well, I want to return more than just one value, or I'm sorry, one variable. So I said, well, just create an array and pass an array. So get the velocity will be a good example for you to see how you can do that. So in my array called val, I have just two elements, vx and vy. And what do I return? Well, I return the name of the actual array. Pay attention to the return value. Is of type double array, right? How do we change the values of x and for v and x and vy? Well, I have independent, excuse me, mutator method or set of methods, set vx, set vy, and of course I have the accessor method for the radius. So technically, do we have a method here that will allow you to change the radius? No, this one doesn't have it. So here's my ball. So now that I defined, I took out of this functional program information about the ball. Now I have to create a driver. Let's take a look at the driver. What does the driver look like? And I'm hoping that you see the similarities between this one and the one at the top, which is not object-oriented. So in the object-oriented, you need to create an object of the class ADT ball. Here it is. Bouncy is then an object of that. And Bouncy is going to have all the information about the ball, from Rx, Ry, Vx, Vy, the radius, all those type of instance fields is the data that belongs to Bouncy. This is the same as the original, nothing have changed over here. And if you look at these lines of code, these two, the if statements in which the actual ball is going to bounce off the walls, it's actually the same thing except that it has different names. And the names are changing because our X now is accessed through a method from the object bouncy. In this case, bouncy, the method Rx plus the velocity. Now velocity returns an array of two elements. We know that the first one is going to have Vx, and here it is. Well, that's why we have the index of 0. Then we need to know also the radius of the ball, and that's why we use Bouncy is the one who knows it. So we have to access that method to give the value of the radius. Now we're going to make changes to velocity. Well, here it is. This is how we do that. We change it with the return, the return value of the first element of the array, and all we do is just change the direction by changing the sign. The same thing happens over here, and that's exactly the same as we do at the top, except that instead of using variables now, we use methods associated with the object. Well, what about how do we update the position? Well, we use the set methods, the Mitosis methods, in which we have the access methods, and the rest is pretty much the same. Well, is object-oriented design more work? Well, yes, it is. It's a little bit more work, but it has there's a purpose for it, which is appealing to a good group of people. Well, number one, like we talked many times about it, had been the fact that encapsulation protects the data, and any type of changes you want to make to the data has to kind of be, scrutinized by the methods, the mutators method of the ADT, the class itself. So that will prevent anything that might be wrong, that might possible go wrong, and it also makes sure that everything is consistent. That's one way to look at it. The other way is that the ball itself is self-contained, meaning all the variables, the instance field, the data that belongs to the ball now is separated from the rest of the actual application. That means that you can use ball and create another object in a different program. We call it sometimes a client. And we can do something else with that. In this case, it's bouncing off the walls. But you could do, I don't know, you can do other type of things with it, like ping pong. You can do a whole bunch of things. And you already have implemented ball. So you're going to be reusing the code. You don't have to write it again. So there are a good percentage of people who like to use object-oriented. I will not say all of them do, because it is always controversial. And different people like to do different things. What I do want you to see is the similarities between the last version of this program, the top one, right? The two of them are similar in some way. And then what makes it different is the one in the middle, which is the actual ball class, the ADT. Now, in your simulation, you're going to go from an ADT to an ADT that is actually using images. So it would look like something like this one. The idea behind you writing first a text-based object-oriented design. So mitosis was that will kind of help you define or design better those classes. And especially because I want to talk about the narrative, the script. We won't be able, I don't want to make it big because this is my second video actually. When I try to make it big, it kind of mess up my recording. But as you can see, take a look. As the simulation is taking place, there is text in the terminal window. You don't have to put it as part of the canvas. That would be more work. I mean, not that it's not possible. It can be done. And there are ways to make it easier. This one, do your drawings with pixels. It's actually really cool. So if you're a person who like to do, excuse me, this type of drawings and with pixels, this is perfect. But again, this student doesn't have script or narrative. Let me come back over here and pause it. Let's take a look at Darcy's. Darcy's actually has pretty good. This is the original cell. Take a look on the right side. The narrative associated with it. Changing the narrative, which is fine. That's not a problem. Or one more thing that I want to tell you is that you can scale the actual images by using a method that is already in the standard draw library. Here's a different kind of formats that you can use for images. PNG has been the most effective for me. I don't know if it is the platform I'm using, but it definitely works very well for me. What else can I tell you about this? Oh yes, just make sure you use double buffering so you don't get the flickering. I'm hoping that this is as fun to you as it is for me, because I like to work with images. So you actually learn object-oriented design with simulations and visuals. If you need more information about it, of course, you can email me, message me. We can have some Zoom meeting or Discord meeting. Just shoot me an email. I hope to see you somehow soon. It would be nice if we can have a Zoom meeting with everybody, or at least everybody who is not camera shy. And